Welcome back to the module 2, session 9. It's a continuation of previous session 8, where in the session 8 we were discussing about the ACR, VI characteristics, the different regions, and how the ACR was working in the two transistor model, and so on. It's a very interesting topic of an ACR. I hope you have enjoyed the previous session, and having known these concepts of an ACR, we are finally going in for the applications of an ACR. So you must be relaxed when hearing about the applications of an oh, finally the ACR has come to an end. Yeah. Applications of an ACR. Further moving on, we have to see about the various parameters or importance of an ACR. Next, variable resistance phase control. This session is very small and sweet. And finally, the references used to create all the sessions of module 2 has been highlighted. Okay. Now, moving on to the ACR, applications of an ACR. Here, ACR, to recap here, we have already repeatedly seen that ACR is a 4-layer, 3-junction, and when gate voltage is 0 or negative, it doesn't turn on. Gate voltage is positive, or that is VG is greater than or equal to 0, the ACR turns on. Once the ACR is on, we can't off. So we are going in for commutation. Commutation means the process of turning off an ACR. So once the ACR is turned on, the gate doesn't have any control. Then we have already seen, if the gate doesn't have any control, how will I make the ACR off? To make an ACR off, we saw the two types of commutations, namely natural commutations and forced commutation. It was a very interesting topic, or very interesting to learn about this, right, about the ACR. Lovely. Now, having known all these, next we saw the regions of operation, how it works, the ACR works as the regions in the 3 modes of operations as forward blocking mode, forward conduction mode, forward reverse blocking mode, and how ACR is closed switch in the reverse blocking and the forward blocking mode. So only during the forward conduction mode, ACR acts as a ACR acts as a closed switch in forward conduction, whereas ACR acts as an open switch in reverse blocking as well as the forward blocking mode. So ACR acts as a closed switch only in the forward conduction mode. Here, when ACR is acting as a forward in the forward conduction mode, ACR is acting as a closed switch. ACR current flows with the help of the current IG, and we took the comparison of IG 1, IG2, IG3, that is the different values of IG. IG means the gate current, and we saw interestingly that whenever the IG value is very close to IA, then anode current, then the minimum time to turn on the ACR is taken care of. Right. Having this in mind, then we saw the VI characteristics, the same application, whatever we have done, the same to same application we have seen. The same to same explanation we have seen, which hold goods for the VI characteristics of an ACR also. VI in the sense voltage and current. Voltage in x-axis, current and y-axis characteristics. Knowing all these concepts of ACR, now slowly we can see where exactly it is used. See, now we told, like we were discussing, like SCR can't be offed. Once the SCR is turned on, how to turn off? We are going for commutation technique. The method of turning on or the process of turning off an SCR, turning off an SCR is called as commutation. And in this commutation, it can't be naturally turned off. So we go in for natural commutation and the forced commutation. So the process of turning off an SCR, when the SCR is in the on state, you have two types of commutations as natural commutation and forced commutation. Okay, fine, the SCR is turned on or we are turning on. Then, even though the concept goes on interestingly like this, where it has application may be a question mark to all of you. So, don't worry. SCR is widely used in power control applications. We look into it. Now, what power control applications means, it has a wide range of applications including rectifiers, half-wave rectifier, full-wave rectifier, regulated power supplies, DC to AC conversion or inverters, relay control, time delay circuits, and many more to list on. So, these are the different types of applications of an SCR where the SCR can be used. Okay, and the details of this, of how it has been used, so we have to go into separate topic elaboration like rectifiers, related power supplies, how it is, where it is, and how we are going to use this and SCR and so on. Okay. The next interesting topic we'll just move on here is a variable resistance phase control. In the variable resistance phase control, here as the SCR can be used, to control the phase of an AC signal. Here, the phase of an AC signal by using a variable resistance, it is an effective method of controlling the RMS value of the current and thereby power delivered to the load. Whenever there is a power delivered to the load, then the triggering or on making the SCR on. See, SCR is here. Understood? SCR is here. On triggering the SCR, an SCR permits flow of only forward current but blocks the currents in reverse direction. Only forward current is allowed but blocks the current in reverse direction. This action is similar to a diode. But an SCR needs to be triggered for each and every positive cycle. Here you can see every positive cycle the SCR needs to trigger positive half cycle. It then produces a constant DC or an average current through the load and DC voltage across the load. Okay, load is near the output wherever state. By adjusting the triggering time here, on positive half cycle of an AC voltage, we can get variable DC output. This method is known as phase control. On triggering SCR, here on triggering means on owning an SCR, making the SCR to be on, only forward current is allowed. There is no reverse current because the current is being blocked in the reverse direction. It means like diode. Diode allows the flow of current only in one direction. Okay, but only thing is here, SCR should be on for every half cycle of positive half cycle. Okay, for every positive half cycle of the input is here. Then whenever it is triggered for every positive half cycle of the input, it produces a constant DC current through load and DC voltage across the load. So by simply adjusting the triggering time here, by simply adjusting the triggering time on the positive half cycle of an AC voltage, we can get variable DC output. This method is called as the phase control and alpha is called as the firing angle. So the time where it has been triggered is called as the firing angle. So A variable resistance phase control is shown here in the circuit. The triggering circuit consists of an ACR, a diode, and a fixed resistor. And here R1 resistor is at where it is being triggered for a variable. The combination of R and R1 limits the gate current which is flowing through the positive half cycle. The combination of R and R1 limits the gate current which is flowing through the positive half cycle of the input. Okay, the diode D, the diode, what is the purpose of this diode is, this diode prevents the flow of the reverse gate current during negative cycle, because ACR has to be only in the positive half cycle of the input, right? So the diode prevents the flow of reverse gate current during the negative cycle. Okay. During the negative cycle of the input. So here for that we have to adjust the R1. So R1 is adjusted to a very high value so that even at the peak value of the input voltage, here this gate current is has a control over the ACR. Okay. Next, moving on, here there are some few, but here you can see here again one more important concept. Here you have something called as alpha. See, the firing angle is called as the alpha. This firing angle of an ACR can be adjusted with the help of this variable R1. If R1 is adjusted for the firing angle alpha, the firing will take place at alpha less than 90 degree. Here, less than 90 degree. At 90 degree, input voltage is maximum. So the operation of the circuit is known as half wave variable resistance phase control. Why it is called as a half wave means only positive cycles is being taken care here, whereas the negative cycle of the input controls with the help of this diode. Okay, so we have only at alpha less than 90 degree. Only if R1 is adjusted, we can get the various firing angle. Okay, so likewise we can have this firing angle conducted anywhere. Now another term we are going to see beta. Okay, now another term, what is this beta here? See, beta is equal to 180 degree minus alpha. As the angle alpha is reached earlier in time, because alpha is here, it is starting earlier than Vi max. Here the operation can be also called as half wave variable resistance phase control. Okay, hence we are seeing here two parameters, namely alpha and beta. Okay, beta is called as a conduction angle, whereas alpha is called as a firing angle. So we have seen how, like ACR, one of the application is variable resistance phase control. How the ACR can be used in this concept. Okay, so this operation of the circuit is also known as half wave variable resistance phase control. Because half wave in the sense, because only for the positive half cycle of the input we are going to get the output graph. Moving on further, we are going to see the various parameters of importance of an ACR. Already we have discussed this. So just as a recap, we are going to see what are the various important parameters of an ACR. First one, we are going to see the forward breakover voltage. Forward breakover voltage is Vf. V suffix F. It is voltage at which for a given Ig the SCR enters into the conduction mode. This voltage reduces as Ig increases. Please recall the graph of three regions of operation modes of an ACR, or the VI characteristics of an ACR. If you just recall the graph, these definitions are very easy and it is self-explanatory. Just recall with the graph. Next, after seeing in the forward breakover voltage, what we had seen, then next we have another important concept as holding current. Holding current is the value of the anode current below which ACR switches from conduction state to forward blocking region. Okay, and we have already seen another current similarly is latching current. Latching current is the minimum value of the anode current required to keep the SCR turned on even after removing the gate signal. And we have already seen IH, that is holding current, is less than the latching current with the help of that three regions of modes of operation or the VI characteristics. Just recall the graph in the mind and we'll come to know about these definitions of the important parameter, which is quite interesting. Okay, next you have in the latching current, we have seen latching current is larger than holding current, or holding current is lesser than the latching current. Recording the graph of this. Another important parameter is the forward conduction region. In the forward conduction region, it is a region in which the SCR is on. If this is a SCR is on, means it is a closed switch and is in the conduction mode. In this region, the SCR conducts forward current from anode to cathode. Another important parameter is the forward and reverse blocking region. These are the regions in which the SCR is off. Off means open circuit. If it is open circuit, no current will flow. No current will flow from anode to cathode. Hence, these are the regions where the SCR is off. Okay. Finally, one more definitions at the end. We are going to see the reverse breakdown voltage. It is a reverse anode to cathode voltage at which Zener or avalanche breakdown of the device takes place and the current rises abruptly in the reverse breakdown voltage. Okay. These are not only the limited parameters. These are just the important. These are the various parameters of importance of an SCR. Likewise, we have reverse leakage current, forward leakage current. Likewise, we are going to see what is gate voltage, what is drain current, what is gate to source voltages, drain to source voltages, and so on. Those are the other important parameters. So these, I just felt that we have to give some of the parameters which was importance of an SCR in order to know the working or the different regions of operation of modes. Okay. Hope the session was very good on the ACR. Hope it has been cleared. And the few references which I had referred to cover all these modules, all the sessions in the particular module 2 are some of this website references. Of course, you can refer for the MOSFET and the ACRs, the books based on the power electronics. And what about the JFETs or this one also, you can refer to that, or any electronic book which gives a comparison between the BJT and the FET and so on. Okay, so these are the few references which I had referred. Of course, you can get more number of references when you just Google onto the net. Hope this session of all the sessions of this module was very much helpful to you. Hope you had benefited. from these sessions. Okay.